Okay, today we're going to talk about a very powerful tool in Excel. It's a add-on called Solver, and you will find it if you go to Data. You can come over to your right here, and it should be over here on the right. Now, this add-in is not automatically there, so you have to basically make sure that you opt for the software to put that in. And so if you don't have this, if you go to the top and go to Data, and then look over here and there's no Solver button, then you need to go to File, go to Options, and look here at your add-ins. So when you click add-ins, you'll see a list of add-ins that are possible and which ones that are which ones that you have available to you. And of course, I've got the Solver add-in. So basically, it's up here under Active Application Add-ins. So you have not, if you've not put it in ever, then yours may be down here. So if it's down here, you just have to click on it and like double click on it and add it into your active list. I'm not really able to do that because I've already added it in. But if you have any trouble with that, just let me know. So once you've added it in and it's installed, when you hit OK, you should be able to see your Solver button up here on the right. Now the Solver is it's a pretty useful tool, and so what I've done here is I've got this equilibrium, one that you've seen 100 times, the Haber process for making ammonia, and I actually need to properly balance this one. Okay, so when we look at this process, you know, if you've actually tried to solve this one, it actually leads to some pretty complex algebra, and although you could probably put it into some of your graphing calculators, I want to show you how to use Solver to be able to solve equations like this, because when you get into a little higher level learning, there may be labs and situations where you don't have any idea where to start for solving a real complex formula. It may have multiple variables, and Solver will can help you with that with some powerful data analysis. So let me show you what I've done, and I want you to try to do something similar. So as you can see up top, I've got my equilibrium constant, and this equilibrium constant is true for 450 degrees Celsius, and it is a Kp, so it's a pressure equilibrium. And then I've got an initial starting pressure of nitrogen of 1 atmosphere, partial pressure of nitrogen of 1 atmosphere, partial pressure of hydrogen of 2 atmospheres. And then I'm going to solve for equilibrium concentrations of everything. And then, you know, the way you do that is you set up your law of mass action, and you can see I've got the 2x squared in this cell. I've got the Pn2 minus x in this one, and I've got the pH2 minus 3x cubed in this one. And then here, I take all of it and put it together to calculate Q. So then what I do is I've put in an x value here, and I just started with something random like 0.1. We can start with something random like 0.1. And you'll see everything changes. But actually now my Q is not equal to Kp, which means that my equilibrium is going to shift or move until Q equals Kp. So we can use Solver to basically change the values of x until Q equals Kp. So what I've done over here is I've done a Kp minus Q, and I want to target this being as close to 0 as possible, and that's where Solver comes in. So if I come up here to Solver, set objectives, and my objective is this cell. I want this cell to equal something, and what I actually want it to equal is I want the value to be 0. So that means I'm targeting this cell to make the value 0. And it says by changing variable cells, and of course I want to change x until this becomes 0 or as close to 0 as the software can get it. And then I'll hit solve. Just to note, you can actually change, like you can have equations with 3 and 4 variables, and you can change all those variables till you reach some sort of objective. In this case, we're only needing to change one variable. So let me hit solve, and then it shows me my results, and it says I can either keep my solver solution or I can get rid of it. I'm going to go ahead and keep it. And if I look, I'm not at 0, but I'm at 4.35 times 10 to the minus 7. And if you look at Q here and KP here, within 3 significant figures, I am basically, I'm identical. I'm the same. So that means that I did find a good solution. And you can see the way I have it set up, it has plugged everything in for me. So it is recalculated these, it's come down here, and I use these X to calculate my actual partial pressures for all of my reactants and products. And of course I can change values here. I can do 0.5, and I can do 3. And I just pick whatever numbers I want. And of course now Q is not equal to KP anymore. Let me change that to a scientific number so it looks the same. There you go. So you can see it's not the same anymore, so that means the equilibrium will shift. So I can go back again to data, solver, and everything's probably already in there from the last time. So yeah, this is my objective, this is my value that I want to change, and I can hit solve. And you can see, once again, it brings it back to a solution. And it does that by continually, it uses algorithms to continually vary X until everything works out. Now, if you can have weird situations where it won't actually solve it because the number won't converge, or maybe there's a mistake on your part, or the formula's one that won't allow the software to actually get somewhere close to 0. But in this case, you should have no problem at all. Once again, if you have any questions, then please let me know. This is a great tool. It's a very powerful tool and an advanced tool. So if you can't figure it out, let me know. I'll be happy to help you do that.